All right, so let's put it all together now. So let's take a look at this and think about this idea of, well, what if other information was given to us? How do I interpret it? And, so we've looked at how we find the equation of a line if we have a point and a slope. We've looked at how we find the equation of a line if we have 2 points. Well, now we're going to find the equation of a line if we know what our line is compared to another line. So we have 2 concepts here to review, and that concept is parallel and perpendicular. So just make sure you got a visual to remind yourself what parallel and perpendicular mean. Parallel means they run side by side, they'll never touch. Perpendicular means they intersect at a 90-degree angle. So kind of get that visualization. So we start off here, and in this case, if 2 lines are parallel, that means their slopes are exactly the same. And that's what we have right here. So the slope of line 1 is going to be equal to the slope of line 2. So like if line 1 was 3 over 4, then line 2 would be 3 over 4 because they're equal to each other. The slopes of perpendicular lines, what would happen is the slope of line 1 might be 3 over 4, but the slope of line 2 would be what we call the negative, let me get my highlighter, the negative reciprocal. 2 things. I often use opposite reciprocal when I do this, and so instead of saying negative, I say opposite. But negatives should make the same thing. So negative or opposite, meaning that if this one's positive, then the reciprocal will be, the opposite will be negative, or the negative of it. And then the reciprocal means whatever's on top will now be on the bottom, whatever's on the bottom will be on top. So the slopes of 2 perpendicular lines are going to be opposite reciprocals or negative reciprocals. All right, so let's apply that. So the way I like to teach this concept is that this concept or this idea that we have your line and we have their line. So in this case here, what we're told is that on our line passes through the point 3, 5. Remember, if we're going to use our point slope formula, we need a point and we need a slope. Well, we don't have a slope. Remember, this is just me talking about what parallel means. So what we do know, however, is we know that this other person has a line. This other person has a line that's like that. So we can find the slope of that line. So we can put that in the slope-intercept form. We can subtract 2x. We can get 5y is equal to negative 2x plus 4. We can divide by 5. And we can find out that y is equal to a negative 2/5 x plus 4 over 5. And remember, the most important thing is that right there, which is my slope. So the catch on this guy is that the slope of their line is negative 2 over 5. But I can go doody and put their slope right here for our slope because our lines are parallel. And if your lines are parallel, then your slopes are equal. So we take that and we start putting it back together. So we have what we need. We're back to our previous slides. And so we take our point slope formula and we take y minus 5 is equal to negative 2/5 x minus 3. I'm not changing colors here. I'm assuming that you're starting to feel better about this whole idea. We get y minus 5 is equal to a negative 2/5 x plus 6 over 5. Use your calculator as needed to check those multiplication. Don't freak out that you have a fraction times an integer. Like I said, we have technology, so please use it. We add 5 to both sides to solve this thing for y. Remember, we got to put it in the slope-intercept form first. So y equals negative 2/5 x. Pull out your calculator. On my calculator, I take 6 alpha y 1 over 5 plus 5. And we find out that gives us plus 31 over 5. So there's the equation of our line that is parallel to the line that they gave us. So remember, this guy right here, this is their line. That's their line. that we used to be able to, that's not how you spell there, sorry about that. This is their line, which allows us to find our line because they share this common characteristics of being parallel. Obviously, please make sure you read the directions carefully. This is slope-intercept form. They may ask you for standard form. I'm not going to go back over that. I'm going to leave that up to you at this point. We've got other videos already show you how to do that. Remember, standard form is ax plus by is equal to c. Alright, well then on the other end of the spectrum though, they might tell us that instead of being parallel, they might tell us that our two lines are perpendicular. Well, if that's the case, I would do the same thing. I would take their line, I'd find the slope of their line, but then when I came across here, I would know that we have the point, so our point is 3, 5, and I would take this slope, and as I brought it across to use it here, I would go doody 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 and do my whole thing, but since the lines are perpendicular, then the slopes are opposite reciprocals of each other. So a negative, the opposite of a negative is going to be a positive, and the reciprocal of 2 over 5 is going to be 5 over 2. So now this is your line or our line that we gathered that information from their line. We use their line to find this information. So now we can say y minus 5 is equal to 5 halves x minus 3. And I can start to solve this. Y minus 5 is equal to 5 halves x minus 15 over 2. I can add 5 to both sides. Go back to black. So I get y, 5's cancel, equals 5 halves x. I pull out my calculator. I have negative 15 alpha y equals number 1 over 2, arrow out, plus 5 gives me a negative 5 over 2. So once again, there's the equation of my line and slope intercept form. If you need it to be put in standard form, read the directions carefully, and then you can watch that previous video. Just remember to try to put it into that format. Alright, so that wraps us up. That's using this concept of parallel and perpendicular lines, and that closes off Unit 2.5.